To our practice set on multi-step equations, where we really start to bring together a lot of the skills that we've been working on thus far. As always, pause the video to complete these problems on your own, give them your best shot with your best work, and then come back to check your work. All right, so let's take a look at these. For these first ones, I am going to do what might be considered overkill with showing the steps and showing that thought process. And then as we move further on, we show fewer and fewer steps. But at the beginning of solving equations, I think it is really, really worth your time to show maybe more than you think that you need to show. So this first equation, we have negative 4x plus 8 is equal to 12. And if we look at the x, we see that there are two things that are being done to the x. So if I were to plug a number in here to say check the answer, the first thing I would do is I would multiply the negative 4 times whatever that number is. And then after I did that, I would add the 8. So when we go to solve this, we reverse that order of operation. So the first thing I'm going to undo is that plus 8. And I will undo plus 8 by adding a negative 8. And whatever I do to one side of the equation, I must do to the other to keep it balanced. Right here, we have 8 plus negative 8. So I know that 8 plus negative 8 is equal to 0, and 12 plus negative 8 is equal to 4. And I know that negative 4x plus 0 would leave me with just the negative 4x. Now, this process here, this is what we eventually will eliminate. Okay, we'll either not show the minus 8 and we'll definitely not show the 0, but it's so important to understand why the 8s are going away. They go away because of very specific mathematical properties. Now, right here, we're going to divide. So this is negative 4 times x, and the most convenient way to undo this, rather than multiplying by the reciprocal, which we can do and which I have done in previous videos, the easiest way to undo multiplication here is to recognize that multiplication can be undone with division. And so we will divide both sides by negative 4. Right here, negative 4 divided by negative 4 is 1. And so this becomes 1x. Over here on the right, we have 4 divided by negative 4, which is negative 1. And 1 times x is simply x. And so showing all of the steps and all of that thought process leads us to x is equal to negative 1. Moving on to the next problem. Is problem number 1. Here's problem number 2. So we have 2 is equal to 1/2 x plus 6, and a similar reasoning here, okay? When you look at the x here, you look at what's being done to the x. If you were to take, say, the number 4 and plug it in, you would do 1/2 times 4, 1/2 times 6, whatever number you want to plug in there, and then you would add the 6. So when we are undoing, when we're trying to get that x by itself, we want to reverse that order. And so the way I'll do that is I will add negative 6. If I add negative 6 to the left, I must add negative 6 to the left as well. And one advantage here of writing it as plus a negative instead of doing the subtraction is if you do want to put it in a line, you can put the negative 6 out front instead of like writing it down below or trying to squeeze in like a little minus 6 in there. It just gets a little bit cozy. Negative 6 plus 2 is negative 4. And over here on the right, we have 1/2 x plus 0. And 1/2 x plus 0 is just 1/2 x. Again, they cancel out. They're gone because 6 plus negative 6 is equal to 0. Now over here, we will use the multiplying by the reciprocal here. So if I want to undo this multiplication, it is a little bit tight, so I'm going to rewrite it. I wouldn't normally rewrite that. I am going to multiply by the reciprocal, 2/1, and I have to do the same thing to both sides. 2/1 times negative 4 is negative 8. And 2 times 1/2, or 2/1 times 1/2 is 1, and 1x is simply equal to x. So as you're looking at your work and you're checking your work, Is it awful if you left out some of these steps? No, not really, because that's the direction we're going to move in anyway. However, make sure that you could show these steps, or looking at your own work, if somebody were to start to ask you questions about your work, that you would be able to explain what happened. Like, I did this step here because this cancels out because, and you are able to give the because reasons for why each thing happens in your work. Next one, solves showing all steps. So number 3 here. Here we have a little bit more going on. We have a copy problem over here. Now I am going to do that quick rewrite just so I am consistent myself. I'm going to write that as plus a negative. So I'm going to take that minus and write it as a plus a negative. And I understand that most people and most teachers do not do that. I find it useful. Now on this problem, we actually have more than one x. We have a 3x and then we have a 2x. And those are like terms because the x's match. And typically what I will do if I'm doing this in class is I will underline, circle, use some colors, to do some different things to make that stand out. If I have 3 x's plus 2 x's, that gives me 5 x's. So we'll have 5x plus negative 5 is equal to 15. And now we're into what's called a two-step equation, which is what we were just looking at. You look at the things that have been done to the x, and then you try to undo them. So I've got that negative 5 there, and I don't want it. So how I can get it to go away is by adding 5. If I add 5 to the left side of the equal sign, I must also add 5 to the right side of the equal sign. Negative 5 plus 5 is equal to 0, which again is why it cancels out. 15 plus 5 is 20. 5x plus 0 is 5x. Here we have 5 times x. So instead of multiplying by 1/5, which is multiplying by the reciprocal, which obviously works, it is easier for us to picture that as division. 5 divided by 5 is 1. 20 divided by 5 is 4, and 1 times x is just x. And so we get x is equal to 4. Now, this last one, I'd actually like to work this one 2 different ways, and you're probably thinking, why do you need to do that? I just want to check my work. But there's 2 really good ways that you might have approached this problem, and it shows a little bit of the flexibility with the solving linear equations. So one of the ways that you could have done number 4 is like so. So you've got distribution. So I'm going to do the little arrows here. Remember that the arrows are not distribution. The arrows just indicate what it is that we are going to do. So we're going to take that 2/9 and multiply it through the parentheses. So we'd have 2/9 times x. And then we would have 2/9 times 18. 2/9 times 18. Well, 2 times 18, sorry, that's plus sign, is 36. And 36 divided by 9 is 4. And that's one way that we can come to our two-step equation. And now we'll solve this the way that we've been solving it. So I have a plus 4 there that I don't want. So I can get rid of that by adding a negative 4. 4 plus negative 4 is 0, and 10 plus negative 4 is 6, leaving me with 2/9 x is equal to 6. And now we will multiply by the reciprocal. Well, the reciprocal of 2/9 is 9/2. And I've got to run out of space here, so sorry about that. 9/2 times 2/9 is 1x. And then over here we have 54 divided by 2. 1 times x is just x, and 54 divided by 2 is 27. Now we could shorten the amount of steps that are involved in that by not showing all the steps, not showing the 1s and the 0s where they come out, but that was what the directions ask us to do. Now, another way that you could do that, so we'll come over here, or you might have said, well, that 2/9 is multiplying the entire side. So it's like the entire left side of the equation being multiplied by 2/9. So if I multiplied by the reciprocal at the beginning and just make sure that I'm doing the same thing to both sides, that should also work. So if we do it this way, we have 9/2 times 2/9 giving us 1. And then 10 times 9 is 90. So we'll have 90 divided by 2. 1 times anything is the anything. And 49 divided by 2 is, 90 divided by 2 is 45. I'm like thinking a step ahead there. And now we actually have a one-step equation. We have the x plus 18. And if I don't want the 18, I could add negative 18. Just make sure that whatever you do to one side, you do to the other. So this gives us x plus 0. 45 plus negative 19 is 27, and x is equal to 27. So you should get the same answer either way because it's a linear equation. There is only one answer. So hopefully you are getting that answer no matter which way you did it. But both of those ways are algebraically sound. And what's really, really important is that you, the doer of the math, can explain what is happening in each step. Now, for these next two, I changed the directions and just said, here, solve it however you want to. So you may show only the process if you wish. What's super, super important is that you understand your own work. You understand the process that you're using, not necessarily how many steps you show. Now, as I am making a habit of, I'm going to change that minus to a plus negative because the most common mistake that you'll see in this kind of problem is distributing a 3 and not a negative 3. So that subtraction sign actually gives you the sign on the 3 saying that is a negative 3. When I go to distribute, instead of showing the negative 3 times 4, I'm just going to write negative 12. So I'm not showing my arrows. I am just doing that multiplication through, but I, the doer of the math, should be able to explain to someone that in that step, I distributed the negative 3. Now, I do have some like terms here. I have 6x plus negative 3x, which is 3x. And now I will simply solve the equation from here. So I have a negative 12 here. I know that if I want to get rid of the negative 12, I need to add 12 to both sides. So what I'll do is I'll add 12 to the left. Negative 12 plus 12 would give me 0, and 3x plus 0 would leave me with just the 3x. Over here on the right, I'm going to do 36 plus 12, which will give me 48. And that's where if somebody were to come and ask you this and say, what did you do in that step? You would answer, I added 12 to both sides. You don't need to show the plus 12 unless your teacher is asking you to show it, which your teacher might, in which case you do whatever your teacher says to do. And then here I would divide both sides by 3. So 3 divided by 3 would give me 1, and 1x is just x. Over here, 48 divided by 3 is 16. That is the process only. You can show all of the steps. You can show some of the steps. So a lot of my students in my class might show something like this. They might show plus 12 plus 12. And then they might show divided by 3 right there, but they wouldn't show the 0 and the 1 part. So you can kind of show everything. You can show just the process, and then sometimes you can hit just pieces of work in between, whatever you're comfortable with and whatever helps you make sense of the problem. Last one over here. And we will start by distributing. So 2 times x is 2x, 2 times 10 is 20. 3 times x is 3x, and 3 times 5 is 15. We have a couple places with like terms. So we have 2x plus 3x, which is going to give us 5x, but we also have some like terms with the 20 plus 15, which will give us 35. Now we'll solve the equation. So I have that plus 35. I can undo that by adding a negative 35. If I add a negative 35 to the right-hand side, then negative 35 plus 35 is 0, and 5x plus 0 is 5x, leaving me with just the 5x. On the left-hand side, if I do 100 plus negative 35, I will get 65. And then here I have multiplication, so I would undo that with division. 5 divided by 5 is 1, and 1 times x is just x. And over here on the other side, if I were to take 65 and divide it by 5, I would get 13. And once again, you, the doer of the math, if your teacher were to ask you, how did you get this 35? You should be able to say, I added 20 and 15. If your teacher were to ask you, where did the 35 go? You would say, I added negative 35 to both sides, or I subtracted 35 from both sides. You should be able to explain what is happening, even if you're only showing the process. And this is a good one. This is a word problem. So like, what does all this math do? What does it model? What can we do with it? That's always a question students have, and it's an excellent question. It does get a little tricky to answer at times, but you are organizing a fundraiser and have decided to sell candy bars. A box of 200 candy bars costs you $150. So you're buying them fairly cheaply, less than $1 a piece from the manufacturer, and you want to make a $100 profit per box. So you want to recoup the $150 and then get another $100 profit. How much do you have to charge customers per candy bar to make your profit goal? So you need to decide what are you going to sell these candy bars for, and to get your target there. So let's kind of pull this apart. So your profit is equal to what you take in. We'll call this like your income, okay? Minus like the cost to you. So in other words, your profit is like the final end game. If you're doing a fundraiser, you obviously need to make a profit. Now, you're going to take in money by selling the candy bars, okay? So you're going to sell 200 candy bars and you're going to make some money off that. But remember that you paid $150 at the outset. So you had to buy the candy bars in the first place before you could sell them. And so you are already like in debt, or you already owe $150. You need that income to be enough so that even when you take away the $150, you're still making the profit that you want to make. So we want the profit to be $100. The income is 200 candy bars times whatever we're going to charge. So I'm going to call that C for like the cost of the candy bar, or the charge, like what would we charge for the candy bars? So if you charge $1 per candy bar, you would make $200, or your income would be $200 for the box. If you charge $2 per candy bar, you could make $400 per box. That would be your income. But we have to take out of that income that $150 that we already paid for the candy bars in the first place. So we've set a target goal of $100 per box. That's the profit we want to make. Maybe that's to get the bus for the field trip. We don't know. So let's go ahead and solve this. So we're going to change that subtraction to a plus negative, just so we're being consistent. If we want to solve for this, we have a negative 150, so I can add 150 to both sides. Over here on the left, 150 plus 100 is 250. Over here, negative 150 plus 150 is 0, leaving me with 200. This is multiplication, so we will divide. And then 200 divided by 200 is 1, leaving me with just the cost, or the charge, on the candy bar. And then over there on the left-hand side, 250 divided by 200 is 1.25. So your answer is $1.25. If you charge $1.25 per candy bar, then you would make $100 of profit off of the entire box. Now that leads to much more interesting kinds of problems, like how much is too much to charge, and when do you lose money, and when do you charge so much that nobody buys it? And that gets into some more complex equations, and personally, I think more fun equations. So as always, please like and subscribe if you found this video helpful, and leave a comment letting me know what you would like to see.